Okay, question 8. We've got some stuff on circuits. Diagram below shows a lamp connected to a DC power supply, so current flowing in one direction only. And then we've got Ohm's law here. So I'm very rich. You don't even need to rearrange it. So it provides 4.5 volts, happy with that unit. 0.3 amps, happy with that unit. And it tells you just got to plug them into that. So 4.5 over 0.3 equals 15 ohms. Calculate the power supplied. So we've got two choices. We can either, because we've got an I, an R and a V all in this part here, I could use the IP violently or the IC pink rabbits with you just selecting the right information. IP violently is probably easier. So calculate the power. P equals I times V. There's our V, sorry, and there's the I, 0.3. Should have put those the other way around. But comes to 1.35 watts. Or I could have used the I squared R. So 0.3 squared times the resistance that we worked out, 15, comes to 1.35 watts. Common question now. Another identical lamp is added in series, and it says state and explain the difference between the brightness. So I've got two bulbs rather than one. Well, we know the brightness would be less, great. But remember, we've got to talk about it in two ways. The current will be less because the resistance has gone up. And then the other thing is the voltage is now shared between two bulbs rather than one. So we're always going to talk about it in terms of current and always talk about it in terms of voltage. So the lamp in the second circuit is dimmer, fine, because there's less current flow as there's more resistance, done. And then the next part is, and the potential difference or the voltage is shared between two bulbs rather than one. So there's two things going on as to why they're not as bright, the current and the voltage. Next one, student is given a low volt power supply and 1 meter of resistance wire. The student uses these and other pieces of equipment to measure the resistance of just 50 centimeters. Draw a diagram of the circuit. Your diagram should identify the pieces of equipment that they need. Right, okay, so let's get a ruler. And let's say it's a 50 centimeter ruler because that makes it easy. So I'm going to have my wire. Now I could, if I wanted to, I will go, I won't write it in full because there, I get my crocodile clips. Next part, let's connect it to a power supply. And then draw that they need to do to measure the resistance. Well, we know we need I'm very rich, so I need the voltage and I need the current. So an ammeter's going in the circuit. I'm going to show off. I'm also going to add a variable resistor, because if you get in that habit of always adding it, that's great. And then a voltmeter needs to go around the piece of wire. Now I'd probably lose, and I promise I've done this on purpose, I'd probably lose a mark now because the voltage is outside of that. All right, so probably a good idea is I bin the crocodile clips, although I could add them, and I stick to the idea that the ruler's there, and there we go. I'm going to put that on that 50 centimeters. After that, because I want to make sure that I'm going around the 50 centimeters, not any further this way or this way. But if you wanted to, you could add the crocodile clips. Just be careful where you're connecting the stuff. There we go, 3 marks. Describe the difference between direct current and alternating current. Direct current flows in one direction. Alternating current changes direction and goes forwards and backwards with a certain frequency. And the one that you need to know for mains electricity is 50 hertz.